All right, so we're back at the command line here, and we just saw that our Vue app is running as expected on localhost port 8081. And I'm just going to go ahead and Control C to stop the process here. So our Vue app is no longer being served. I'm going to clear the screen, and you can see we're still in this solarcoffee.frontend directory. So I'm going to cd up one directory back into our project root. And now I'm going to go ahead and create what's called a solution file in .NET. And a solution file is really just going to be a way for us to group various parts of the .NET program that we're building together. And to do that using the .NET CLI, I can just type .NET new SLN. So solution files are suffixed with the SLN file type. And you can see that the template solution file was created successfully. If I list the files in the directory now, we can see that it's named the name of the directory we're in. So you should have solarcoffee.sln in this directory. Now we're going to create each layer of our web API layer. The web API layer itself will consist of several layers. And again, we can use the .NET CLI to generate each of those different layers. So the first layer we'll create, I'll call the web layer. And so we can do that with the command .NET new web API -o for output. And we're going to output it as solarcoffee.web. So this is actually going to use the template ASP .NET Core Web API. And so that's going to scaffold out a new .NET Core Web API project, and we'll take a look at that in just a moment. You should now have a new directory in the project root called solarcoffee.web, and we'll take a look at that in just a moment. Next, let's go ahead and create several different class libraries that we're going to need to build out the other parts of our Web API project. The first will be the data layer of our web API, and so I'm going to do .NET new class lib, and then we're going to say -f .NET Core App 3.0, and then -o solarcoffee.data. This is going to create a class library, and a class library in .NET is just basically what it sounds like. It's a collection of classes, and we generally create separate class libraries, again, to sort of separate concerns at a level of abstraction that's higher than a class, but more specific than an entire solution. So an entire solution may consist of many different class libraries and perhaps different web applications. In our case, we'll have this web layer piece, and then we'll have a number of different class libraries that, that support it. And so the first one that we just created here is the data layer. We're going to create two more now. The next one we'll create is going to be called the service layer. So we'll do the same sort of thing here. .NET new class lib -f .NET Core App 3.0 -o, and we're going to call this one solarcoffee.services. And so this is going to create a class library called services, and this will be where the various services that support our web API live. Again, we'll take a closer look at that here when we actually start developing. Finally, we're going to go ahead and create a test project to house our unit tests. And this is kind of a nice feature of the .NET CLI, which is we can do .NET new XUnit, which is going to tell the CLI to set up a test project and specifically use XUnit as our test runner. So XUnit-f, the rest of it is kind of the same here. .NET Core App 3.0-o. We're going to say solarcoffee.test. We'll talk more about XUnit when we start writing tests. There are other great test frameworks for .NET. Previously, I've used NUnit for a lot of things. MS Test was also popular early on. These days, I prefer to write unit tests in a framework called XUnit. Okay, so if we take a look now at everything in our root of our project here, you can see that we have our solution file, we've got our Solar Coffee web test services data, and this front-end application, which is completely separate. That's our Vue app. The next thing that we need to do is actually add the class libraries and the web project that we created to our solution. And so the way that we link those up is with the command .NET sln add, and we're going to add solarcoffee.data. And you can see that it says that our project Solar Coffee Data CS Proj added to the solution. We're going to do the same for the others. So services, test, and then finally web. We'll talk also about the CS Proj when we open up the project in an IDE. But first, let's go ahead and just make sure we can run our web API. So we can actually just cd into the web API directory. And if we take a look at what's in here, we can see that it's already scaffolded out quite a bit for us. We have a program.cs, a startup.cs, we have our CS Proj, we've got some controllers, a directory called properties, and interestingly, .NET Core, at least at 3.0, has this weather forecast. So it kind of sets up a sort of prototype of a web API here using the theme of weather forecast. It sets it up for us, which is, I guess it's kind of nice to see something before you actually get started. In any case, we can actually run it just by using .NET Run in this directory. Okay, so we can see that our .NET Web API is running on port 5000 on HTTP localhost, and over HTTPS we're running on port 5001. So let's just go ahead and visit port 5000 on HTTP, and we'll take a look at exactly how the different routes are set up in just a moment. If we actually visit localhost 5000 now, we won't see anything because of the way that the project is set up by default. By default, the project is set up with a single route, and it's actually at /weather forecast. So let's check that out. And again, you're going to want to make sure that you are visiting the HTTP version, otherwise you'll get a protocol error here. So what you should see if the API is running is this sort of JSON response here. There are different plugins that you can get for Chrome to make the JSON response look a little bit prettier and to sort of automatically format it. But you'll know that it's working if you do see some data here. And it's interesting, we have the date, it looks like, and then some properties, temperature C and temperature F. If I refresh the page, you can see that the date's updating and the temperature is updating as well. That's because the default implementation here, which we'll take a look at in a moment, is just is creating some random numbers here. Kind of an interesting example. Like I said, maybe a little bit too much and a little bit strange, but that's the way that the .NET Core CLI is currently generating a default project.